Okay, ready? Okay, so that's just basic notation covering sequences and series. Obviously, we need to know what the summation symbol represents. Okay, remember summation is just a lazy way of writing a whole lot of numbers as one term, as one amount. Okay, and then we can obviously identify different values or terms in the actual sequence or series. Okay, so your first one is arithmetic. That's number one. That's what we're looking at, the first one. Okay, I'm changing the sequence slightly because arithmetic is actually the easiest sequence. Then you can look at geometric, then you can look at binomial. Okay, those are the three that the work program requires you to cover on page 41, 2, and 3, and so on. Okay. Right, so the first one, number one, arithmetic sequence. Okay, so something is arithmetic, what does that mean? It's simple. Do you agree? There's no multiplying, there's no dividing, it's just adding or subtracting. That's it. So arithmetic is using arithmetic. Arithmetic is adding and subtracting. So that's the easy way of remembering what it is. Okay, so bullets. A sequence with a common difference. That could be the definition for an arithmetic series. A sequence with a common difference. There are formulas that you need to know. The textbook's actually really good here. On page 132, they summarize the two equations that you need for an arithmetic series in terms of n terms. So I'm going to literally just take what they've given you here as a summary and just use the same equations. Okay, so you can say, you can put a big heading here, NB, equations for arithmetic series. Page 132. There's two that you need. Okay, so if I know what type of series I'm dealing with, I'll know what formulas to use. If it's an arithmetic sequence or series, I'm going to have to use these two equations. Can't use any of the others because they relate to different series. Okay, so the first one is, maybe just put a heading here, an arithmetic series of n terms. Right, there's that whole notation story we spoke about a bit earlier. Okay, n represents the number of terms. Okay, the I is identifying which term are you looking at.
Arithmetic series of n terms.
Yes. Yes, just to recap that, the n is representing how many terms. So over here, how many terms do I have? In this basic example, 1 to 10. Okay, if I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, the n is 10. Okay, do you agree each term has a specific place? Right, so if I look at the third term, what is the third term's notation going to be? x3. Okay, because the I is representing the specific term in the series of terms. Does that make sense? Okay, so you asked what the difference is between I and n. N is telling you how many terms do I have. So how many terms do I have here? 10. Right, the I is, well, what term are you looking at? Are you looking at the first, the second, the third, the fourth, the fifth? Which term are you looking at? Okay, so that's important, and that's why you've got to always write that down, because these equations give you amounts based on the number of terms. So equation number one. Ready? Okay, equation number one. L stands for the last. Okay, last. So L, we can write on what they represent. L. It's an L.
Can we just write it down in case it's L equals?
L equals A plus bracket n minus 1 bracket D. Okay, so what does the L represent? The last term. What does A represent? The first term. N we already spoke about, that's obviously the number of terms, and D is what? The difference, the common difference. Okay, they talk about this word common difference. Okay, it's basically revision from last year when you did sequences and series. Okay, you also covered arithmetic and geometric there. I don't think we covered binomial last year when you did maths. Binomial looks new for this module. Okay, but all that stuff that you covered previously with arithmetic and geometric, that still stays the same. Okay, you're gonna see the same equations. These are the same equations. Okay, and then you need to write down that formula there. There's two different ones. They're both exactly the same, right? But it just depends on what you're given in terms of the question, right? Sometimes it's easier to use the first, sometimes it's easier to use the second, but they're going to give you the same thing. Okay, so write down both. Write it down as is. S equals a half n brackets a plus 1 close bracket. That's the first one. Second one, half n brackets 2a plus open brackets n minus 1 d close brackets. It's just two formulas that can basically give you the same thing. And that's what S is what? Sum. Okay, that's not a 1, that's an L. Okay, it's A plus last, yeah. Okay, you wrote it down right. I think I said 1. Okay, I'm reading it backwards. Yeah, and then the second one has a minus 1. That's right. Okay, so notice the only thing different is what? The end bit. L is denoted by that formula. Okay. Just little notes. Right, so those are the formulas that you've got.
What does this stand for now? Why do you use these ones?
What does S stand for? Sum.
Okay.
And then all the other stuff stays the same. L stands for the same thing you wrote at the top. A stands for the same thing you wrote at the top.
Yeah, I get that, but now, in which cases would you use this one with half? Yeah, you've got two.
Okay, so what does the first thing say? It says S equal.
Are these two separate equations?
Yes. Okay, so what does S equal?
Half n.
No, but what is S? S is the sum.
Yeah.
Sum. So what does that mean?
So what is sum?
Sum is sum, so add up everything. Okay, so what is the sum of 1 to 10?
10.
55. It's 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 7 plus 8 plus 9 plus 10.
Okay.
That's sum. Okay, so sum means add up everything. Add up everything. Add up all the terms. Okay, so if I've got 10 terms, I'm going to add up 10 terms. If I've got 20 terms, I'm going to add up 20 terms. Okay, so the sum is representing everything, all the terms added together.
Okay, so then why is this a half now?
It's just the formula. It's like why does the area of a triangle half base times height? It's the formula. Okay, we're not going to look at how they derived the equation. We're just going to use the equation. But there is a mathematical proof to that. Even this textbook doesn't go through that. Okay, the formula is the formula. Okay, so what does that formula give us? The sum of all the terms of the expression. Okay, so the expression could give you 10 terms. 1 plus 2 plus 3 plus 4 all the way to 10. If I sum up all of them, that's the formula that I'm going to use. If I wanted the last term, I'll use the first equation. Okay, so let's look at an example. Let's see. Okay, in terms of the textbook, they give the same thing. Okay, the textbook example is actually a bit easier than the ones with the work program examples are easier than the textbook ones. Okay, the textbook ones use bigger numbers, 100, 120, 140. Okay, those are big numbers. Let's use the small numbers. It's easy to calculate. Okay, so e.g. E.g., example. Okay, so this is looking at a series. So the series that you need to write down, 3, 7, 11, 15, 19, 23, dot, 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 dot. Can that series go on forever?
Yeah.
Yes. What type of series is this? Yes, okay, because that's what we're looking at. Okay, so how do you know it's arithmetic? It has a common difference. That's the first step. Step number 1, get the difference. What is the difference going to be? The one term minus the other term, right?
Yeah.
Okay, so the next term minus the first term. That makes sense. Okay, so how do we write that in mathematics? We don't write down English. Okay, so we write down this. This minus that is what the difference is equal to. Do you agree? Because this fancy symbol xn plus 1 tells me that that's the next term. Xn tells me that's the first term before it. Okay, so can I apply this notation to anything? Yes. Okay, so I'm going to write down what I wrote down there. Well, what you wrote down. 3, 7, 11, 15, 19, 23.
So that would be 7 and 3 equals 5.
No. 7 minus 3.
7 minus 3 equals 4.
Okay. Right, do you agree you looked at the first two terms? Could I have looked at the fourth and the third term?
Yeah.
Okay, so let's just get this notation story right, because you were asking a lot about notation earlier. So look at this. What term is this?
First.
The first term. What term is this?
Second.
And this?
Third.
And this? The fourth. So now if I wanted to use this equation, xn plus 1 minus xn, and I wanted to look at those two, what am I going to put into the equation?
11.
I'm going to put in 3, okay, because I look at the third term. So what's 3 plus 1? 4. So this is x4, and this is minus x3. So what is x4? 15. What is x3? 11. What's 15 minus 11? 4. Okay, so that's the application of the notation. Okay, so what am I looking at? I'm looking at many terms. Okay, I don't know how many. There could be many. I mean, that dot, 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 dot goes on for infinity. Okay, but you know that every term is going to have what? A common difference. So what is that 4 representing?
The common difference.
Okay, write that down. That was step number 1. Get the common difference. So now, do you know what the common difference is? Yes, you do. Okay, so can you write an equation for L? Okay, so what is L going to equal? Yeah, they use the notation L. You could have used the position of n plus 1, but it's fine, L. I'm going to just stick to what they've given you in the textbook, L, because L could stand for the actual term that you're looking at.
Okay, that's step 1. Step 2. So now we've got our common difference.
Okay, can you get an equation for L?
Equation for L.
Yeah, is it possible to get an equation for L? Yeah. You could replace the L with an xn. Okay, because you don't always have to look at the last term, because there is no last term here. This series goes on forever. So the L is xn. Okay, you could represent it as xn. Okay, whatever term you're focusing on. Also xn.
Okay, so it will be xn equals the first term.
What is the first term?
Plus 3 plus
The n stays the same, and the d changes. Okay, so now can I work out, let's say I wanted the, how many terms do they give you here? 1, 2, 3, 4, 5, 6. 6 terms. Okay, so if I wanted term 6, what would the calculation be for term 6?
Just say x6 equals 3 plus 6 minus 1.
Yes, let's do that. So to show the actual application of it, that's all. You can even do it in pencil next to it. Okay, but I'm just trying to show the use of the actual formula. Okay, so if I wanted the 6th term, the 6th term would be representing x6. Okay, because now you have the general equation for the xn. Okay, so if I was, let's just say if I was looking for the 6th term, which we know what it is, we can see it in the actual series. Okay, remember this series goes on forever and ever and ever. So you could find the 100th term if you wanted to.
Okay.
Yes. Gives you? Should give you the same answer as what you've got in the actual question. Perfect. Is it the same? Mm-hmm. Yes. Okay, so assuming we didn't know what the 6th term is, could we work it out? Yes. Could I work out the 100th term?
Yeah.
Alright, just out of curiosity, let's see what it is. X 100 equals what? This could have been a separate question altogether. Right, the question could have said, calculate what the 100th term is in that series. X 100 will equal 3 plus 100 minus 1. Good, times 4. So 99 times 4 plus 3, whatever that is. $399. Okay. Right, so do I know what the 100th term is? Yes, I could work it out. I don't have to write down 100 terms to get what it is. Right, so now what happens if I asked you to sum up the first 6 terms? What would you do? Okay, so you can make a sub-question to this. Sum up the first 6 terms. Sum up the first 6 terms. Right, so if I'm going to sum up the first 6 terms, can I use a formula? Yes, I could. But before we use the formula, let's see what the answer is actually going to be. Okay, so what we're going to do, we're going to write down all 6 terms. Write down 3 plus 7 plus 11 plus 15 plus 19 plus 23 equals. Okay, that's the long way of doing this. We don't have to do it that way. I just want to show it to you so you understand what these formulas are actually showing. Because at the beginning, I felt that the notation probably confused you a bit.
So I write this whole thing on.
No, not that. Let's first do it let's do it long way, then we look at that formula. Okay, so what is the sum of the first 6 terms? Well, what are the first 6 terms? 3 plus 7 plus 11 plus 15 plus 19 plus 23. What does that give you? Okay, so that's what we would have done if we knew what all the terms were. Okay, but that, do you agree, is a very long process. Okay, what happens if I ask you to calculate the first 100 terms? It's going to take a while. Do you agree? Okay, so is there a quick way of doing it? Of course there is. There's a formula. That's why you've got the formula. 10, 21, 36, 36 plus 19, 55, 55 plus 23, 78. Okay, that's right. Right, so what is 78 representing?
The sum of the 6 terms.
Of 6 terms, exactly. Only 6 terms. Right, is it possible to use a formula instead of having to do it that way? Of course. Now you can write down that pink equation. Don't write down both, choose one. Which one do you want to use? Do you want to use the first one or do you want to use the second one? Now you've got 2 options to choose from. The textbook's good. They gave you 2 options. So page 132 in the textbook gave you those 2 equations. The first equation to me looks a bit easier than the second one, but it's up to you. You can go for whichever one you want. They both do the exact same thing. They give you the sum of those number of terms. Okay, so which one are we going to use? First, second? Okay, so using that one, first one. Okay, so S equals a half n brackets A plus L. Right, so how many terms am I adding up?
Okay, so sum.
How many terms am I adding up?
I don't know how many going to. 6.
Yeah, that was the instruction, 6. So it's going to be a half.
So S equals to a half.
What's n going to be?
6.
6, because I'm adding 6 terms.
6. A is the first is 3 plus the last.
What is the last term of the 6 that I'm adding?
23.
23. Yeah, 23 is the last term because I'm adding term 1 to 6. So the inverted commas L is the 6th term, okay, which is basically xn. Xn would have been x6 here, which is L. Does it make sense? Okay. Alright, so on the calculator, plug that in. A half times 6 times 3 plus 23. And you should get the exact same answer, 78. But let's check. Okay, what do you know? You get the exact same answer. Right, so that's that section. Okay, geometric now. That's the first one. That's the easiest one. That's where they should have started. Okay, they obviously covered binomial as the first one. We'll come back. As long as we cover all three, we're good. Okay. Alright, so now let's take it one step further, so a little bit more difficult, geometric. That's slightly different to arithmetic. Okay, so that was number 1. This is number 2, geometric. Is that making sense? It's not too bad. I'm sure it's coming back to you. Probably like, oh yeah, kind of recognize that from previously. Now, arithmetic and geometric we have covered from last year in that other module you did. So it's mainly revision, just to recap. Okay, number 2, geometric series. Okay, chapter-wise, geometric series aren't covered in chapter 8. Chapter 8 in the textbook was called series. Geometric is separate on its own. It's chapter 13 in the textbook. Sorry, 14, not 13. Mistake, 14. Geometric series is 14. Okay. Right, perfect. Same as arithmetic, you need 2 equations. It's quite similar, except what do you think the difference is?
It's not a common difference.
Yeah, you're not going to have a common difference. You'll still have a difference, but it's a ratio. Okay, so it's a common ratio. So you can say a series of numbers with a common ratio. And this is the multiplying and dividing, okay, rather than the adding and the subtracting. Okay, so arithmetic is adding and subtracting. Geometric is using a common ratio, which is, inverted commas, multiplying or dividing. It's either making things bigger or making things smaller. Okay, so again, we'll use the simple example in the textbook.
So the common ratio difference.
Common ratio, don't write the word difference. Okay, difference is looking at minusing. Ratio is looking at like multiplying or dividing. Asterisk, you can say multiplying or dividing. Okay, so I'm going to use the example in the work program because they're easier, the numbers are a bit smaller. Well, when I say smaller, it's relative because you're multiplying. Yeah, we can. Okay, so the equation, the nth term, is this. See? Where's it? There. The nth term is un equals ar to the power n minus 1.
So this is to find the nth term.
Yeah, it's just to find a term. Okay, what's the r?
Okay, so
What's the r?
What's the u?
It's just a term. They've just used u in the textbook while work programs.
So it could be xn.
Could have been xn if you really wanted to put an x. Okay, what's the r?
Not sure.
Here we go. Okay, so now is it important to get a ratio? Very important. Right, so the ratio could be times 2, so would be a 2. The ratio could be a half. Okay, then it'll be divided by 2. Does that make sense? Okay, so a half would be divided by 2. A 2 would be times by 2. Okay, so let's look at the example here. 2, 6, 18, 54. Let's stop there. 2, 6, 18, 54. Okay, the numbers get bigger, obviously, because you're using geometric. 2, 6, 18, 54. Right, are those numbers getting bigger? Yes. Multiplying or dividing? Multiplying. Okay, so how are you getting from 2 to 6? How do you get from 6 to 18? Times by 3. So what am I looking at? The ratio R is what? Xn plus 1 over Xn. Does that make sense? So if I'm looking at the first one, I'm going to have X1 plus 1 over X1. So that's X2 over X1. What is X2? X2 in this example is 6 over 2, which is 3. Okay, you're doing it like how they did it last year. Okay, remember we did that. But remember, last year you did even higher level geometric series. I don't know if you remember, we took it to second levels. Right, so what you're doing here, remember we did those V's, the differences? You had the 3 of the first difference, and then you had another difference, which was the second one. In your textbook this year, you don't have to go that far. Okay, it's just the first step, and that's it. Okay, so what you did there was correct in terms of getting the difference, the R.
So this is the formula for R?
Well, yes, because remember, what are we trying to work out? The common ratio. Yeah, so R is representing the multiplying or dividing by a number. Okay, so common ratio here is 3.
Okay, so if we had to do it in the formula 1, then it would be xn plus 1, which would be 6. 6 over 3, which equals 2. 3. Right.
Yes. Okay, so now that's the one formula. The other formula is this one. You can write it down as is in the textbook. Write down both because it might be easier to use the one or the other. Depends. Okay, but you only need one of them to calculate it. So yes, okay, there. The sum of the first n terms. Okay, n is always representing the number of terms. So I could add up 10 terms if I wanted to, 100 terms if I wanted to. But I'm going to use that formula. Yeah, write down both. Sn equals a brackets 1 minus r to the power n close bracket all over 1 minus r. That's the one. And then equals, and then write down the other one as well. Okay, either or is fine. I would just remember one of them, the easiest one. Okay, so the first one's probably the best. I would maybe just stick to that one and then just practice using it. Okay, so what does that thing represent? Yes, of X number of terms, or N number of terms. Right, so how many terms did I give you? I only gave you 4. So let's just add up 4 terms. So if you wanted to sum up the 4 terms, what would you do? You'd add up 2 plus 6 plus 18 plus 54. Do you agree? Okay, so let's show the long way like we did before with arithmetic, and let's show the short way. Okay, so the long way would be to add up every single term. But there's only 4, so that's not too bad. Okay, so start by writing that down.
What does it say?
Sum up the first 4 terms. So if I was summing up the first 4 terms, doing it the long way, you would have 2 plus 6 plus 18 plus 54. Okay, like we did there. Okay, we showed it long and then we showed it short. 2.
Does that show it long and short?
Yes, of course, yeah. Show it because it shows understanding as well. At least you can study directly from these. Yeah, like you did there, yeah. Okay. Yeah, so when you had 4, obviously this could go on for infinity if you wanted to. Okay, so what is that added together? Okay, so now we know what the answer should be. Obviously, there's a better way of doing it. We're just going to use the formula. So you wrote down the equation. Sn equals A brackets 1 minus Rn over 1 minus R. Okay, so write down that equation as is and substitute everything in. Okay, so using the equation, substitute in.
R is 3
Yeah.
to the
N.
4.
Yes. Okay, why? 4 terms. Okay, if you were adding 100 terms, the N would be 100.
Okay.
Did you do that on a calculator? Check it. Yes, it probably does come up to the right answer, but it's better to check. 3 to the 4 is what? 3 times 3 is 9. 9 times 3 is 27. 27 times 3 is what? Sure. Does it work out? It does. Very good. Right, something else that they've taken into consideration here. So that was kind of what you did last year, but there's another little bit that adds to the geometric. Okay, so what we just discussed is what they've got here. They also talk about an infinite geometric series. Okay, it's the same thing, just taking it one step further. Right, so let's just make a note. For geometric, we have finite and we have infinite series. Okay, so finite is what we just spoke about. Infinite is what we're going to look at now, summing to infinity. Okay, so this is just a subheading for geometric. Infinite geometric series. It's a continuation of what you had there. It's just something else to consider. Okay, so if something is finite, there's an end. Okay, so if I start, I'm going to end. Infinite, it doesn't end. Okay, so underneath this you can write a bullet. The work program, the textbook here, well, the notes here say, when the common ratio is between -1 and 1, the series converges to a limit. Okay, so let's write that down.
Infinite.
Infinite means the series doesn't end. It's continuous. Okay, so let's write down what they said. When the common ratio is between -1 and +1, comma.
Common ratio.
Yeah, when common ratio is between -1 and +1, comma, the series converges to a limit. Okay, so is it possible to calculate a geometric series where the common ratio is greater than or less than -1 or +1?
What does converges mean?
Converges means it moves towards number. So converge. So like for example, converge. Two cars on the road are driving toward each other. Okay, they're going to converge at the intersection. Okay, so it moves like toward each other. Okay, so converges to a limit. Converges to a limit means it goes to a specific number. Okay, it reaches the number, it goes towards the number. Okay, so here they've given you an example. I'm just going to discuss it with you first before we look at it. So if I have an infinite series, infinite means the series never ever ends. Okay, if the common ratio is between -1 and 1, then we will have an answer because it'll converge to a limit. If it doesn't, if the common ratio is bigger than +1 and smaller than -1, right, that will be infinite forever. Okay, it'll just get bigger and bigger and bigger and bigger, and it'll get smaller and smaller and smaller and smaller. Right, so here they said, this is just some notation. You can write it in. So absolute value r less than 1. That's the first thing. Okay, absolute value we've spoken about. There's two lines with an r in between. Okay, it's got nothing to do with vectors. It's just an absolute value. Absolute value of r less than 1. Less than 1. Okay, what does that mean? It means if I take an r, which is a ratio of the series, the common ratio, and if that's less than 1, then you're going to have this. Rn, write down r to the power n. Just r to the power n, just as the next step. Okay, this is the theory relating to the infinite geometric series. R to the power n, arrow means converges to. Okay, so r to the n converges to a 0 as n converges or gets bigger to infinity, approaches to infinity. Okay, those are the different restrictions. So here's the formula. Sn, okay, converges to S infinity equals A over R, 1 minus R. 1 minus R. Okay, equals, yeah, S to infinity equals, A, it's an A over 1 minus R. Let's put an A on top. Okay, that's the formula. Alright, so when does that apply? Only when I have a common ratio between 1 and -1. Right, if I do, then we would assume that the Sn, which is the sum of all those numbers, would sum up to a number that would be a limit. Okay, it would be seen as a limit. It's like tending towards a specific value. Okay, moves towards a value. Okay, notice that it only applies if I've got -1 or +1 and something in between. Okay. Makes sense. Great. Okay. Then we've got the last section, which is binomial.
Why would you use this formula?
To work out the sum to infinity. Okay, that's an Sn. Sn, arrow converges to S infinity. Right, so A over 1 minus R is used to calculate the sum, the limit, to infinity. Right, so what does that series add up to if I'm looking at the sum towards infinity? Okay, towards infinity meaning, remember we can't substitute infinity in, but we know what it can converge to. Converge means the answer would become bigger and bigger and bigger until it reaches a specific amount. Okay, which is the limits towards infinity, sum towards infinity. Okay, then you've got the third one, which is binomial, and that other chapter. So let's go back. That was chapter 14. The textbook covers binomial in chapter 9, 138. There's it. Okay, it's not much, it's just a page in the actual work program. The textbook gives you a lot more detail though, which is good in a way, but it might be a bit too much. So I'm going to stick to the work program. It's just a page and a half. Okay, so page 39. This is number 3. This was the first one actually that they covered, which I don't think is a good idea because it's actually a bit more tricky to understand binomial than it is to understand geometric and arithmetic. Arithmetic and geometric are common. Okay, so that's the third option. Right, so if I'm looking at a series, same thing applies. It's a sequence of numbers. Okay, this is binomial. So binomial is special. Okay, what does binomial mean? Let me get your definition from the textbook. Here they don't describe it. They just give you an example. Let's see. Okay, so the best way of putting it would be maybe you could say relating to exponents. So the reason why they've given you so many workings here in the textbook is because they're showing this whole idea of expanding an equation with an exponent. So for example, x plus y, close bracket to the n. Okay, binomial means you've got two different variables and you're expanding it. Okay, so I've got x and I've got y and I'm expanding it. That's why it's a binomial series. Okay, binomial means I've got two different components of the series and it gets bigger or it gets smaller. Okay, so let's write that down. Binomial, you can say two separate variables, e.g. x and y. Okay, I'm not going to give you this whole proof here, but it's worthwhile looking at it if you want to. So you can just say, see page 139 textbook. Okay, that gives you the they actually show you all the expansion. So they expand x plus y squared. They expand x plus y cubed. They expand x plus y to the 4. Okay, it's just too much to write and it's not really important. It just helps with understanding. Let's obviously keep it focused on what is in the work program. Okay, right, but what you should know is that what are you expanding? You're expanding a fraction, not fraction, an equation, okay, or a function by an exponent. Okay, so you can just say exponents. Exponents are used. Exponents are used. Okay, an exponent is a power. Right, so the one that you need to cover in terms of the textbook, work program. Okay, the textbook is a bit more detail, but a bit too much detail. You can go through that just now if you want to. We'll discuss some of it, but let's write down this one. This is the one that you need. Okay, so work program wise, binomial series, but what series? You're going to be looking at this series. Bracket 1 plus x close bracket n. That's the binomial series that you're going to be looking at. Okay, so don't worry about any other binomial series. There's lots, and binomial can be used in other applications as well. This is just one of them. Okay, it's the heading there. It's that bold heading. Okay, because the textbook here goes on. If you look at the other pages, they've even brought in. Okay, the factorials is something that you might or might not know. We'll mention that just now, but that's looking at the calculation of the binomial question. And that's it, yeah. Okay, so let's stick to the series. Okay, can I take that again? Okay, great. Alright, so in the work program, that's the binomial series that you are going to be focusing on. A series where you have 1 plus x to the power n for any n. Any n means I can have 10 terms, so 1 to 10, or I can have 100 terms, 1 to 100. Right, n is just the number of terms I'm going to be observing. Right, so the theory says if you have a binomial series of bracket 1 plus x to the power n, this converges provided that absolute value x is less than 1. So put a note there. If absolute value x less than 1. Yeah, like that. Less than 1. That's greater than 1. Yeah, other way around. Less than 1. Okay, yeah, so if absolute value is less than 1, what does that mean? It's basically what we wrote down on the previous page. Remember geometric, we spoke about less than 1. Okay, and if it's an absolute value, it's going to tend towards infinity. That's what they say here. Okay, converges. So converges means it will end up in a specific place. Okay, so you can say this will converge to a specific answer. Right, so e.g., we need an example. Right, that's the theory. It's just it's talking to this whole idea of a raised to exponent, a variable raised by an exponent. Okay, so it's exponential. Right, so e.g., expand bracket 1 plus 3x close bracket to the minus 2. That's the exponents. Expand bracket 1 plus 3x close bracket, yeah, all to the power minus 2. Okay, so what are we looking at? We're looking at a binomial series. Why is this binomial? It's a bracket with x raised to a power. Okay, that's what we've got. The basic equation is 1 plus x raised to a power. Right, so what would you have to do? You'd have to first write down the terms. Okay. Right, so the first term number 1 would be what?
So A.
Substitute. You can write down A if you want to, but A is very specific to arithmetic and geometric. Here, there isn't a specific formula for it.
Okay, so first
yeah, so you can just say x1 as the first term.
x1 equals?
Okay, so what would x1 be?
1.
Substitute the 1 in, yes.
1.
Okay, so that'll be brackets 1 plus x, 1 plus 3 times x, which is 1, close bracket to the power 2. Okay, what is x1? 1. So what is x? 1. So if you put in 1, 1 is going to be put into that.
Yeah.
Yeah, right? Because that's the term. So you're going to substitute a 1 in there.
Okay, so substituting. Okay,
Yeah.
x1.
Well, the first term is x1, so you have to put in 1.
1 close bracket square. Now I'm missing.
Okay. Right, so what are we putting in? The 1 for the first term. Okay, so then they said plus. Plus would be the second term, right? Okay, so what would the second term be?
So now we're substituting terms.
You'd have to put a 2 in.
Now
Second term.
do this. Must be...
Let's just show it first. Show the substitution. You can type all of that into the calculator later. x2
equals 2.
you're going to substitute 2 in, right? Okay, so just put a 2 in there for x. Okay, and then you can say continue to substituting. So depending on how many we're looking at. Right, the textbook said they were going to look at the first 4 terms, right? But you can see the numbers get really big. I mean, have a look. If you're multiplying all of that out or multiplying all of that out, the numbers get big. Okay, so obviously we're going to have to work out what these things are eventually, but it's not necessary here. Okay, even you'll see they talk about conversion. That's the important bit. Right, so what does this converge to? Well, what did they say earlier? This converges provided that absolute value x is less than 1. Okay, so is absolute value x less than 1? Yes or no?
Yes?
Is absolute value x less than 1?
I don't know.
Okay, well, what is the absolute value for x? If we're looking at x, x is a number based on the binomial series. So the binomial series is brackets.
In the calculator.
No, don't put that. That was just to show the substitution. Okay, and you would continue for however many terms we were looking at. If we're only going to look at 2 terms, we would only have looked at 2 terms. If we're looking at 5 terms, or in this case in the textbook, 4 terms, then you have to put in 4 of them. Okay, but like I said, the numbers get big here. You can see the substitutions are massive. You've got numerator, denominator, squaring. It's big. Alright, so the point here is the convergence. So what did we say earlier? If x, absolute value x less than 1, okay, this will converge to a specific answer. This converges provided that absolute value x is less than 1. Right, so what is your binomial series? It's brackets 1 plus x, close bracket, n. Do you agree? Okay, so looking at that, you've got 1 plus 3x, close bracket, minus 2. Right, so if I'm looking at the bracket 1 plus 3x, okay, 1 plus 3x is going to give me what? Am I going to get a number less than 1? We need to solve. 1 plus, no, 1 is separate. It's not 1x, it's 1 plus 3x. You can't add those 2 terms. Yeah, we're solving for x. So what would x be equal to?
So solve for...
Okay, so 1 plus 3x equals 0. Solve for x. You should get a third.
What about this?
The squared is just giving you the binomial series. That's, remember, n to the power. Yeah, 1 over 3. Okay, but absolute value. So is that going to be positive or negative? Absolute value x, so absolute value that would be positive. Okay, because remember you drop the negatives if you have an absolute value. Right, so now do you have, if x is less than minus 1, do you have x less than minus 1? Less than 1. Is a third less than 1? Is a third less than 1?
No.
Is a third less than 1?
Yeah, it is.
It is, yeah. Okay, so third is what? 0.33. Recurrent, right? Or 1 over 3?
Yes, it is less than 1.
It is less than 1. So you can say, therefore, this series is convergent.
Less than 1. Therefore, yeah?
This series is convergent. See, that's how they prove the convergence here. This series is convergent.
Yeah.
Okay. Okay, so that's that. Let's see if there's anything else here. Okay, you can write one other note at the bottom there just to sum up this bit. They've given me an example here looking at powers greater. So just as an example, just put a note there. If the function, so f of x, if f of x equals 3x minus 1, if f of x equals 3x minus 1, all over a denominator of, okay, all over, denominator is x squared minus x minus 6. That's the denominator. Right, so that's the function. So you've been given a function. Find the expressions of 3x minus 1 all over x squared minus x minus 6. Right, then they say in ascending powers of x up to x squared. So now, if I'm looking at this term, okay, what's the highest power that you've got in this term?
2.
x2, good. So just write a note there, the power equals 2. Right, so this can be expanded, and you could expand that further if you wanted to, because remember, you're looking at something with a power. So do you agree this would be a what series? A binomial series. So you could have a function that looks like that. That could be the function. All right, that function could be expanded, and they don't even show that because they said the sequence is any list of numbers, and if that's the function, you would substitute any x in. So if you wanted the first number, you'd have to put in 1 here and 1 there, and then you'd get a term. And then you'd have to put in 2 and 2 to get a term, 3 and 3 to get a term. So this is just one very big formula to give you what? A term. Okay, so remember, just to sum up what we've covered today, okay, what is a series? It's a sequence of numbers, 1, 2, 3, 4, 5, 6. Okay, if these numbers go up in terms of plus or minus, what is that? Which series? Arithmetic. Then you'd use that, then you would use those equations. If it's times 2 or divide by a half, geometric, exactly. And then the last one is when you have a function where you have an exponent of 2 or greater, and you need to plug in values into the function in order to get a term. Then those are the terms that you would have. Each term is going to be calculated using that formula. Okay, so it's just a different way of getting a different term. Okay, and those terms will follow a specific series. Okay, so the series follows a function. Okay, so all those numbers, do you agree, whatever those numbers are, all those numbers are in relation to that one function. Okay, if I use this function, every single answer that I get will be based on that function. Answer 1 would have come from this. Answer 2 would have come from this. Answer 3 would have come from this. Okay, that's why this function is important to use. And the reason why they've given you binomials is because sometimes you do get higher order exponents. Okay, like this. Just to end off here, see? We said reference this page. This is to the power 2, that's the power 3, that's the power 4. Okay, look how long those calculations are to get to that answer. Now, can you imagine substituting something in to get that? Those numbers are big. Okay, so this is just one way to solve or to expand a bracket to make it simplified. Okay, because remember, this is the factors, that's the answer. That's the factors, that's the answer.
Yeah.
Okay, right, and then that covers that section.